So now that we got some of this code behind us, one thing I bet you're starting to imagine is, especially when it comes to types and variables, depending on what you want to do, some of that could actually get kind of unwieldy, especially when you're trying to come up with a bunch of different variable names and being as unique and readable as you possibly can. Well, today we're going to handle something that's going to actually try to make that a little bit easier. This will be that your first collection type called an array. So let's get into it. Hi there, I'm Roy, and welcome to My Code Corner, where we talk about subjects of computer science and technology, and especially with these tutorials, get a little hands-on. So if you like this kind of thing, definitely go ahead and hit that subscribe button below and come join the community. Now let's jump over to the compiler and see what we can do. So obviously, sitting here in the compiler, let's start thinking. Let's imagine you are trying to build a program that we'll say contains a bunch of scores. You want to keep track of how many times you scored in something, whatever it is. And of course, I'm going to go ahead and create these very not readable names, but something quick. Imagine, let's say you had 6 scores, and let's say we're going to say one, you did 1 point, touchdown, home run, whatever it is. Go ahead and for Y, let's go ahead and say this was a good day. We did 5. For Z, mediocre day, 3. A make 3 again. B is a great day. We're going to go ahead and do 6, and then we'll end this one with 5. So 6 different variables, 6 different, in this course, this is being an integer. As you can think about, it's going to be very difficult it'd be very easy to use things like your ifs or your switches or whatnot like that. But, we just went through a couple lessons of loops. And this right here, trying to figure out how to go through this would be problematic. Well, as I mentioned, there are what's known as collection types. Now, I'm going to show you the first collection type. Now, this one is a C collection type. When we start really going into the C++ things, and that I'm probably going to delay a lot of that because there's some other topics I want to talk about first. But at least for C, this is the base one. There's actually only 2 collection types in C, and of course this one being the array. Now, what is an array? Array is basically a contiguous piece of data that holds multiple values of the same type. As you can see here, we have the integer. So an array would hold multiple integers. You would not be able to cross the streams per se. You couldn't say, okay, I'll have a couple integers and a couple of characters and maybe a float or two. That just doesn't work. They have to be the same type. Now, how do you declare an integer? It's actually extremely simple when you think about how did we learn to do basically data types. So let's imagine we're going to go ahead and take this 6 scores here, and we are going to go ahead and create an integer of those scores. All I have to do is say int, because that's the type. We're going to go ahead and call this scores1 for the lack of a better term. Still being not very readable. And this is another reason why you like collections, because you don't have to come up with all these different variable types, because I am pretty terrible at that, like most of us are. But I have scores1 here, and this scores1 is going to hold a total of 6 integers. The way you do that to convert this simple integer to an array is after the scores1, you put square braces and a semicolon. But this is an uninitialized array. And so one of the things when you're talking about data types, even the collection types, you've got to give the compiler an idea how much memory to hold. Now, with this one, it wouldn't know. So what I'd have to do is inside this square brackets, tell it how many values is this array going to hold? Because that's the thing about an array. They are fixed size. So once you declare the size of an array, the only way to make it bigger is actually to create a bigger array and copy it into. But we won't go into that right now. We actually won't go that with this lesson. But I want to go ahead and create this array that holds 6 values. And all I have to do is say 6, and that's it. So really, this array, it tells the compiler, create basically a spot in memory that I can hold six integers in. Now, what if you want to go ahead and initialize it? Same thing. Go ahead and hit int. We'll go ahead and call this one scores2. And how many times I'm going to actually miss the S on these, just keep your eyes open for that. I am going to go ahead and put this, oh, not the parentheses, put the square brackets. And instead of putting a number, I'm going to go ahead and fill it out. So I'm going to go ahead, just like we did data types before, where we just assign it a value, we're going to go ahead and assign it 6 values, because we are going to basically mimic what we did up here. Now, I can't just go 1, 5, 3, 3, 6, 5. Because if I do that, that's a syntax error. It really doesn't know what to do with it, because this looks kind of strange. You got to kind of package it all up. And that was actually one of the reasons I kept hitting the wrong keys before. What you want to do is when you have these initializations, you want to surround those kind of like a code block, but with those curly braces. So what this tells is that I have an integer, I have an array of integer type. I don't have to put anything here, because when I specify these 6 values, it knows the size is going to be 6. That's all it is, one of these 2 ways. Now, of course, one of the dangerous parts about us, basically creating an array like this, it's uninitialized. So the values that are inside that is anybody's guess, but it's going to be initialized to something. So just a word of warning that could potentially, what it's going to be. Assume you don't know, bad things happen. As I mentioned always before, don't deal with uninitialized values. Now, back when we were actually covering data types, we always wanted to make sure we knew exactly what was in those data types. Matter of fact, we have 2 collection types, 2 arrays here. We want to go ahead and see what's in them. Of course, how do we do that? As we did last time, we have scores underscore 1. I remember the S. And indel. And we're make sure it's two carets there. We're going to go ahead and see what's in the uninitialized one and what's in the initialized one. So for fun, let's go ahead and hit run with these 2 couts printing those arrays and see what happens. And you're actually going to be a little bit surprised if you don't know already. So hit run, wait for it to build, and what does it have? It gives me, these are very, very interesting things. These 2 very, very long values that don't look anything. And the fact is, they're actually pretty close to each other when you think of numerically. These being hexadecimal numbers, of course. But it don't look anything like that 153365 that we put into that array. Now, why is that? Let me go ahead and close this. And we're going to first, before we jump into exactly what's going on, we're gonna do something a little bit fun here. Something that we are going to cover later, not this lesson, but we will cover this. You're going to get to learn and use this quite well. But I did put this cout indel here. Basically, it's going to do really nothing. It's going to print a blank line. But the reason I put this here is that I needed something to stop the program. One of the things when you start debugging, when you start learning that technique, realize that since I'm using Visual Studio here, and it's different in different environments, but we're going to look at Visual Studio. But these IDEs, these integrated development environments, one of the things it does have is what's known as a debugger. These are there to help you trace through your programs whenever you start getting errors. We are going to go over debugging. I think it's a very, very important topic. and I don't want to short it any whatsoever because, again, it's an extremely powerful, especially when you start getting into more complicated stuff. But right now, I wanted to do it to show you why is this, when I printed the scores 1 and scores 2, did it give me some very bizarre values. So what I'm going to do on this line that I created that really means nothing is I'm going to go ahead and hit the right over here to the left. You see this little red dot. That red dot is called a breakpoint. And there is some buttons up here at the top. And remember, we usually click this, looks like a play button that's not filled in. But you notice there's another one here, and it says right beside it, Locals Window Debugger. I am actually going to hit that one. And what that will do, that will actually run this code in debug mode. And reason I put a breakpoint there is because it's going to do that very thing. It's going to it's going to basically break execution. So let's go ahead and hit the local Windows debugger and see what happens. And it goes ahead, builds it like normal. And of course, let me move this over just a bit here so you can see it. If you notice, actually, let me move it around quite a bit here. If you notice there's a lot of things going on. The program is actually still running. But not only is it running, over here on this left side, you'll see these are actually some diagnostics tools that are important in some cases, but in what we're doing right now, not really that much. Let me move this over again. What I really want to look at is down here at the bottom. Now, this bottom right side says call stack, and that race basically, we'll go deeper into that one. We're not going to worry about this right now. Call stack's not very deep because we were not running a bunch of instructions. But what I really want to look at is over here, these autos. And what this is known as, this is the watch window. And if you notice, you see a scores 1 and a scores 2, just like you do up here in the code. And on the scores 1, of course, you've got a caret. And what's good about that is I can actually drop it down. Actually, before I drop it down, look what's here. You have the value and you have a type. And of course, that type being the int 6, which means this is an array of 6 characters, or 6 integers, that is. You got your value. We're going to talk about the values in a bit. I'm going to drop these down, but one thing I want to point out, if you look real close here at the very beginning, and of course my tooltip comes up when I hover over it, you notice there's that one of those values. It might not mean exactly what it did, it might not be the same as it was before, but you see these huge numbers here in hexadecimal. And just one thing to know, it starts with a 0x. That's definitely a way in C and C++ to say this is a hexadecimal number. This is for us, not for the compiler, because it knows it's hexadecimal. But you see these big numbers, and then you see, of course, there's the curly braces, and here on the second one, there's my 153365 in the curly braces, and then the one above it, you see the negative 858993460 multiple times, which tells me that's what the value it is whenever it's uninitialized. But that doesn't explain what this big number at the very front is. Now, one of the things when you're dealing in C, C++, or a lot of these more systems type languages is that these deal in memory. Actually, all programs deal in memory, but that really means something very specific. And we're in about, I want to say, 3 or 4 episodes from now, we're going to go very deep into this, and we're going to do it for multiple, because this is honestly one of those topics that will take multiple times for it to stick. It's also one of those topics that tends to confuse a lot of people. So we're going to go very deep into it. But what these are the addresses. This is the address in memory where this data resides. Of course, they're pretty much next to each other, but that right there, other than it telling you where it is in memory, it really doesn't mean too much, at least from a printing out point of view. Now, if I drop that caret down, like I mentioned before, I can see that there's every one of my values, and of course what every one of my values is with being an integer. And of course, do scores want to do the same thing, and I noticed every one of those has its own value, and that's what it is. So when you print out, I'm gonna go ahead and get this to continue on. Of course, I can do that one of two ways. Let me move this down a little bit so you can see. I can either hit this red here to stop execution, it stops debugging, or I can actually, these are the ways you'll walk through. Of course, we'll go over it later, but I can go ahead and say step out, which basically means go ahead and pass my breakpoint and continue on. Of course, that means finish the program. And so be back to where we were, and we'll close it. So covered a lot of material right there, but what you see is that, I'm gonna turn off this breakpoint while I'm at it, comment this one out. You notice that that is not a way to actually see what's in these arrays. The arrays are actually made up. It's a collection. It's a collection of, basically a collection of variables all put together in curly braces, kind of like what you saw here. And we saw the way to look at it, but of course, how do we get to that data? Since obviously we just can't print it out. Well, just like we did before, just like, when we were dealing with data types before, if we had an integer, we would just say, imagine, let's say scores underscore 2 was an integer. We would just say scores, just like that. Actually, go ahead and just like these, but I'm going to go ahead and comment those out. But if this was just an integer, this would print out just fine. But this is not an integer. We know this is really pointing to a piece of memory. What we want to do is kind of like on a bookshelf. Imagine this scores 2 is a bookshelf and has 6 books in it. And I want to pull out one of these books. So what I would actually do, once again, use those square brackets. And then inside those square brackets, I would actually put the index of the value that I want. So imagine I want value, let's imagine, let's say we want to pull value 2, right? We want to pull this 5 out. And so if I look at this, and I could say, well, if you think about it, what would I put? Would I put a 2? Let's go ahead and hit run and see what this does. And remember I told you how many times I'm going to forget the S. There's 1. So it's scores underscore 2. Go ahead and hit run again. And if you notice, it says 3, not 2. Remember, we said index 2, expecting this 5, but we got one of these 3s instead. And to push this a little bit, say 1, 2, 3, 4, let's say index 5. So the assumption is we're going to pull this 6. Actually, if I hit run, you're actually going to find that it's not. It gives me that 5. This is another one of those cases that causes programmers a lot of errors, especially when you're new to coding. Most of the time when you're dealing in indexes, it's basically 0 based. So instead of like normal, you expect 1, 2, 3, 3, or sorry, 1, 2, 3, 4, 5, 6. You actually say, oh, this is index 0, 1, 2, 3, 4, 5. So even though it has 6 values, since you're starting off at 0, it's kind of like European floors where the lobby level is not 1, that's 1 up. This is the same way. So it's always 0 based. And you'll get used to that, but a lot of times when you're getting a value you doesn't feel right, check to see if you're off by 1. Very common error. So in this case, let's say if I want this first one, I would actually say index 0. And if I hit run, it will give me a 1. Easy peasy. What about obviously we have scores underscore one has 6 uninitialized. Of course, we know if I actually put one here, I can hit run here and it's going to give me that uninitialized value. It's not giving me anything bad. It's just giving me a value, probably not one that I care about. Well, just like before, whenever or when we're looking at this, we can index it in by reading it. We can do the same thing for writing or to write out to the memory. So let's say scores underscore one. I'm go ahead and give it an index. And if I hit, let's pick position 3. Of course, that means it's the fourth one in my values. I'm going to hit that. I'm going to give it a value of 42. You know, this life, the universe, and everything. And I'm going to go ahead and set a breakpoint here on this cout because I really don't care what it is. I want to go back and look at memory. Again, get used to the debugger. You'll be playing with this quite a bit. And I'm going to go ahead and hit that local Windows debugger once again because we're going to go look at that watch value once again. Make sure I can get this out of my way. And of course, you can see right here, the arrows telling you where we are in the instructions. But the important thing to see is actually, there's my scores 1. I'm going to go ahead and drop this down. You notice scores 2 is not there. And the reason scores 2 is not there is because I'm not going to use it anymore here. So it's really, even though it's still in memory, the debugger is trying to make it as easy as it can for you by just kind of ignoring it. This is known as an auto watch. You can set up, you know, where I'm watching all the values. Don't worry, we will cover this later. But let's go ahead and drop this scores 1, just like we did before. And you see there's all of our uninitialized values. And then, of course, in position 3, just like we had here, there's my value of 42. Go ahead and step out of this. It won't finish the program. And of course, it gives you an error because it will say cannot be completed because we kind of finished it off. We don't really care. And we'll go ahead and turn off our breakpoint. So that's it when it comes to reading from a value in an array and writing to a value in an array. That's all. Now, important thing to remember is that now in this case, we have 2 arrays and they're of size 6. Now, what would happen if I'm going to go ahead and try to write to position 6. Use my code here. So I'm going to try to write that 42 to position 6. What will happen? If I hit run, it's going to go ahead and give me an error. As I mentioned before, type safe language means it's going to try to protect you as much as possible. We don't want to run from our last time because we want to see that error tells me that index 6 is out of range. Basically, you're trying to write beyond what the compiler allocated for you. Can't do that. Bad things could happen. Old compilers would sometimes do that, but fortunately the more modern ones don't. So go ahead and set that back to 5. So when we run this, this is going to print just like normal. And there we go. All right, what else can we cover here? So we know how to read, we know how to initialize, we know how to write to a position. Also realize that these collections, they are what's called mutable, which means you can change the values. You know, I didn't have to do anything special. All I had to do is tell what the index is and write to it. Now, how do I know the size? Since, you know, we do know the compiler held so much memory for us. How do I know how much? Well, if you remember back when we were talking about data types, there was a function that we were using. And if you remember correctly, and if not, we'll kick it back up a little bit. There was that function of sizeof. Well, sizeof, the fortunate thing about sizeof is you can actually drop an array in there. And so let's go ahead and pick scores. I'm not going to forget this time. Scores underscore 1. We want to find out what the size is. So if I hit run here, And you notice it says it's 24. So there's 24 bytes in this array. But that's kind of strange since we know an integer is only 4 bytes in C++ on Windows. This one is 24. Well, I want to show you a little trick. Since sometimes you may get an array and you don't know how many values, how big it is, really. You might, and when we move into functions, which we're going to do in a couple, you may get some data that you really don't know how big it really is. So in this case, scores 1, we know if there's 6 values in it, and we know it's made up of integers. But imagine if we know we're getting an array that's made up of integers and we don't know how many. Now, of course, we did this before. We can actually do a size of an integer. And of course, that should tell us, this is going to tell us the 24 like we did before. And this is going to tell us the size of an integer, which if you remember correctly, was 4. Went wrong. And I'm going to forget characters all over the place today. Go ahead and hit that run again. And there it is. So we got the 24 tells us how big the array is, and we have 4 tells us how big of the value, which is an integer, it is. There is a fun little thing to remember. I'm gonna go ahead and do an int of length. And in that one, I'm going to actually say, I'm going to do a little math calculation. Let's say my mouse is acting up today. I'm going to say the size of scores underscore 1 divided by size of int and put that on the outside. And then I'm going to go ahead and do a C out of length. And you're probably already guessing what that is just because you know what those two values are. And it tells me it's a 6, which is the number of values that's in that array. So good little thing to remember. If you always want to find out how many values is in an array, as long as you can calculate the size of the array and divide it by the size of the type, that will tell you the length of the array. And you will use that more times than you realize. So it's one of those things to throw in the back of your head. How do I find out how long an array is? Divide the size of that array by the size of the data type that's in it. Now, I am also, one of the things I want to call out is that in this case, I'm using integers. And the reason I'm using integers is because integers are nice and easy and I can play with numbers and whatnot. Realize that array can be any data type. So if you want characters, if you want floats, if you want doubles, if you want unsigned integers, you name it, you can put it, as long as what you do is that when you define it, you define the data type it is. And of course, each one's going to be different. Obviously a character would be, instead of each one being 4, it'd be 1. So, something like this, if these are all characters, it'd be 6 bytes. And of course, if you're doing characters, surround that with ticks. But we're not going to do that. So just wanted to call that out. An array can be of any type. It's just going to be not a mix of types. It's going to be all that one type. Now, one of the reasons why you would like to use a collection type like this is that I mentioned these scores. Again, these scores can be anything. He says, how many strikes got called against you, how many, you name it. You pick your sport, whatever you want to do. It's all up to you. Maybe this is golf and that you got a hole in one and did whatever. tell I don't play a whole lot of sports. I know a lot of sports, but I don't play a lot. But one of the nice things about a collection is that you're grouping like data together. And because you're grouping like data together, you can interact with that like data together. I mentioned when we first started this right here would be a little bit difficult trying to come up with a way to loop through all of these values. Well, looping through all of these values is actually really, really simple, especially the fact that we know the length. And of course, since we're dealing with something that's looks a little bit familiar if you think about what we were doing 2 episodes ago, is loops. And so, of course, great loop for this one is for loop. Now, in this one, let's imagine I'm going to leave this blank for right now because we're going to think about it. I'm going to do I++. Go ahead and finish this up. Of course, we are going to go ahead and print. I'm going to do scores2 because I know scores2 actually has values across the board. Endel, so I don't get another compile error. But we want to go through and print out every score in scores2. And so we know we're going to print out 6. Now, what would I use here? Well, there's 2 things you could do. You could, since I know the size of the array, and I want to basically go up to the end of the array, I could just say 6, right? Because I know there's 6. We are starting at 0. Notice that one of the nice things, remember, is that because of being off by 1, start this one at 0. If I started this at 1, actually it would skip that first position here. But I could put 6. Perfectly valid. However, this is very, very bad practice. When you actually put a fixed literal in your code like this, these are typically known as magic numbers. And magic numbers is one of those, you're kind of forcing it. You're not using something programmatically to write what you want it to do. You're kind of forcing its hand, right? Magic numbers are typically very, very frowned upon. In a peer review, you will get tagged on this one. Now, what would be better, and part of the reason why I calculated this length, is to use length. And so in this case, if I hit run here, and let's go ahead and, before I write all this one out, let's go ahead, actually, let's add, just so we know what we're doing. Go ahead and do it again, because that made a mess. And there's our 6 scores: 1, 5, 3, 3, 6, 5. Notice that they're still in the same order as we put up here. It does not mix it. Order matters in an array. So that's all we did. We walked through all 6 values. And it wouldn't matter if this is 6 values or 600 or 6 million, it would still walk through it just fine. And you could simply, by changing the amount of data in it, also because we actually did not use a magic number, we used a calculated length, not a problem. It will handle itself. This is why magic numbers are bad, because you'd have to change it in multiple places, especially when you start passing these into functions, which is going to come in a couple lessons. But that's one way of doing a for, or a loop through this data. But that's actually not the way people typically do. And there's actually an easier, and that's part of the reason why I chose array as the next step. This is almost loops part 3. Yes, this one we recognize. This is exactly what we did 2 lessons ago. But when it comes to arrays and collections, there are built-ins that help you. And how would we do that? Well, it would still be a for. It's funny, it seems like everything becomes a for loop. But what we're going to do is we're going to define, get that out of my way. We're going to, we'll call this value. And afterwards, we're going to put a colon, and then we're going to call out the array that we're actually talking about. So we have int value colon scores. And go ahead and put our code block here. Now, what does this mean? So in this for loop, scores is the array that we're going to walk through. This is the collection we're going to walk through. Value, first off, it has to be of the data type has to be the same data type of the array. But this value is a built-in way of saying in scores, give me a value and go through the entire set. And the value that it gives you, I can now use. So I'm going to take this line here, copy it, and instead of the scores calling an index, I'm just going to say value. Because what's going to happen, let's go ahead and say this is 2 so we don't confuse ourselves. I'm going to go ahead and print this, and we're going to talk about what it just did. And you notice it looks exactly the same. The number's the same. It doesn't change the order. It just basically went through it without having to do any sort of calculation. Because what it does, what this for does, this basically says that in this array, take a value, put it in the value of array, use it, and when you go back through, iterate to the next one. Put it into the value, use it. Iterate to the next one, put it in there, and over and over and over until it gets to the end of the loop. I'm sorry, end of the array. Notice I don't have to worry about a length. I don't have to worry about a magic number. The other nice thing about doing it this way is that, let's say this length here, let's say I decided I wanted to use a magic number, and I know my array is 6, but I want to go ahead and say less than, equal to, equal to, not plus. What would happen here if I hit run? Because in this case, this will go from 0 to 6. So this will be inclusive of 6. So this will actually loop through 7 times. And I'll show you why that's a bad thing. So hit run. Basically, it jumped into, oh, that's really interesting. It jumped into this negative, basically uninitialized value. Sometimes it'll do stuff like this, even though we have now blown past the end of our array, but it put into a piece of memory that still kind of, I don't know where that's coming from, but we are actually outside of our array. We are actually beyond the bounds of our array. Remember when we put this directly, it gave us an error. This is a case where sometimes it will give you a weird value like this. Sometimes it will actually just blow up. It really depends on what that next piece of data is. And again, in a couple, maybe 4 or 5 episodes, I don't remember off the top of my head how many. I actually do have them planned out, but you're going to see why that's actually a bad thing. So you really be very careful about this. And that's why things like less than length is a good thing. So that's it when it comes to arrays. They're pretty straightforward. So we'll go ahead and let's talk about our challenge problem. I'm going to make this challenge problem actually extremely simple. So basically what I want to do is I'm going to give you a nice simple one. I'm going to give you the following grades, and you go ahead and take those numbers, load it into an array, which I've shown you before, then loop through that array, and then calculate the average grade. This is a very common use of arrays, and get you a taste of how can you actually use this. So that's it. Let's go ahead and jump back to our end slide and talk about what we talked about. So that was a quick foray into arrays. We did talk about initialization, both an uninitialized and to fully load one up. We talked about how to access values, how to modify values and insert values. Of course, it has to be within the array size itself, and then showed a couple ways that we can loop through an array. Of course, we did spend a little bit of time, a very little bit of time with the debugger, showing a little bit what you have to play with. We will go deeper into debugging because I feel that's a skill that not enough people learn, and it's a very important skill. But that was it for today. The next session, we're actually going to go next step into arrays. That would be the multidimensional arrays, because arrays actually can get quite complex, and there'll be some other things that we're going to cover with that. But that's it. Hope you enjoyed another step into C++. Of course, these are a C type of array. There will be more advanced ones that we'll deal with when we're really going into the C++ pieces, but that's going to cover, there's be some other stuff that we'll have to go over first. But I definitely hope you enjoyed it. If you did, if you want to be part of this, definitely become part of the community, hitting the subscribe, and hit the thumbs up if you like what we're doing. Make sure you go ahead and try the challenge problem. I will put up a short on Friday of my solution. It can be more than one. And as long as you get the right answer, there's so many different ways to code. It's always good to practice, because it's one thing to watch a video, but you got to get your feet wet to actually start understanding code. But hope you enjoyed it, and I look forward to seeing you the next time. So until then, bye now.